atmospheric pressure and wind, or how the sun's energy gets a flag to fly. Please watch the following video.
I have a jar of water and a regular index card. Why is the index card not falling off? Why doesn't the water fall out? It's wet.
What do you think caused the water to stay in the cup when it was overturned? You have some choices offered, or you can come up with your own explanation. You will need to enter this as well as the other questions, answers to the other questions in this video in the Kia survey for the video notes. The secret word is notes. Now pause the video to answer the question. When you're finished, turn the video back on. Now, let's get started. Pressure anywhere in the atmosphere is due to the weight of the air above it. Air is being pulled to Earth by Earth's gravity. It does not press on us or squeeze in, holding us. Rather, the Earth itself is pulling the molecules of the atmosphere toward Earth with gravity. Now recall, as you move up in altitude, the density of the air becomes less. The pressure of the air also becomes less. This is due to the fact that there is just less air on top of you. Notice the person here at point 1. And then if you look up the hill, up the mountain here, the person at point 2 has a lot less air sitting on top of him than the person over here grilling at point 1. The fact that pressure decreases with altitude has everything to do with the number of molecules above and around you. More molecules exist at lower levels because of the force of gravity. When the molecules collide, they exert force on things that they collide with. Thus, the more molecules there are equals more pressure. Now, when you're at a lower altitude, sea level for example, there are more molecules of air colliding and causing pressure. All of this is because of the compressibility of air. Air can squish in around itself. There's nothing containing it. So as the gravity pulls the molecules to the Earth, more of the molecules can gather down here closer to the Earth. Now at ground level, changes in temperature can cause a change in pressure. Recall that as air warms, the molecules of the air become less dense and rise, creating a lower pressure. And when the air cools, the air becomes more dense and sinks. Sinking air is higher pressure air. This will be important to remember when we're discussing wind. Gravity pulling on your mass causes you to have weight. We measure this weight in the U.S. in pounds. Everywhere else in the world measures this with kilograms. Air's weight is expressed as a weight over an area. So imagine a column of air that is 1 square centimeter around and as tall as the atmosphere. This column of air would weigh 14.7 pounds. This is expressed by saying that the weight of air on you is 14.7 pounds per square inch, or anywhere else in the world they would say 1 kilogram per square centimeter. Now try the following air pressure challenge. Consider, pressure at sea level is 1 atmosphere. 1 atmosphere is equal to 14.7 pounds per square inch, or 1 kilogram per square centimeter. See if you can calculate how much air pressure is on the surface of a dollar bill when it's lying on a table. You'll need to calculate the area of the dollar bill. Once you have it figured out, record your answer in your science notebook. You will put your answer in the Kia survey after you finish taking the video notes. You can check your answer when you get to class. Now pause the video. See if you can figure it out. Something to keep in mind is that air also exerts pressure all around an object, not just down on an object. Air pressure is always pushing on things. If there is space under it, there is air pressure coming from that direction as well. Now, air can only push. It cannot pull. When something is affected by air pressure, it is because a greater pressure pushed it. Air cannot pull anything. Thus, suction is not a matter of air pulling something in. It's a lack of air in one area that allows a greater outside pressure to push on the object. Think about this the next time you use a straw. Now, moving air acts in interesting ways. When air is moving, it actually creates an area of lower pressure. This is called Bernoulli's principle, and there are a lot of cool things that happen when this principle is applied. Airplanes can fly because of this principle. Think again about the question that you answered at the beginning of the video. Think about what you've learned so far. Have you changed your answer? What do you think caused the water to stay in the cup when it was overturned? Record your answer in your science notebook. You will again record this in the Kia survey after you have finished the notes. The water didn't spill out because the water that was inside the cup is lighter than the air outside. The card is held in place by 14.7 pounds per square inch of force from the air pushing up on the card, while the force of the water pushing down is only about 1 pound of force. Now let's talk about how air pressure is actually measured. Scientists use a tool called a barometer to measure air pressure. There are two main types of barometers. The most widely available, most accurate kind, and the oldest, is called the Mercury barometer. Now, the classic Mercury barometer is typically a glass tube about 3 feet high, with one end open and the other end sealed. The tube is filled with mercury. This glass tube is inverted so that the open end sits in a larger container called the reservoir, which also contains mercury. The mercury level in the glass tube falls, creating a vacuum at the top. The first barometer of this type was devised by Evangelista Torricelli in 1643. As the pressure of the air exerts force on the surface of the reservoir, the level of mercury in the tube is also affected. If pressure increases, the level of the tube rises, and if pressure decreases, the level in the tube drops. The problem with the mercury barometer is, well, mercury. It's a highly toxic element that causes neurological problems with exposure. It's also very persistent and dangerous in the environment, so there are many legal controls now on the use of mercury, especially that of the public. Scientists in labs still use these barometers, but they are under very controlled conditions and carefully stored. They are not very portable. So, of course, none of this was known in the 1600s when this barometer was first developed. As the knowledge about mercury became known, the search was on for an alternative barometer. Around 1700, Gottfried Leibniz, the co-inventor with Isaac Newton of calculus, my doom when I was in college, suggested that changes in the thickness of a hollow disk surrounding a vacuum could be used to measure air pressure, but technology at the time was not up to the task. Things were better in 1843 when the French inventor Lucien Vidi made and developed the Aneroid barometer. This term means without liquid. Changes in the thickness of the capsule are transferred to a needle on a graduated disc by a system of levers. Knowing that air pressure differs at different altitudes, and also knowing that air temperature can affect air pressure, how do you suppose meteorologists account for the different pressures at different parts of the country to be able to convey information to a large audience? Pause now and write your answer in your notes. You'll enter this answer in the Kia survey after you have finished all the video notes. Think you have it? Scientists make corrections to standardize the measurements to sea level. There are a series of calculations and tables used by meteorologists to account for the differing pressures due to altitude, temperature, and also latitude. Everything is adjusted to the standard of sea level air pressure at 32 degrees Fahrenheit and to the latitude of 45 degrees north. The other units you'll need to know when discussing the pressure of air regarding weather are inches of mercury. Hg is the symbol for the element mercury. You'll hear the local weatherman on TV refer to the pressure most often in inches of mercury. Millibars is the unit used on weather maps to draw the isobar lines. You'll see these numbers used on many of the maps that we look at. We'll talk more about isobars when we discuss how weather is observed. Now let's think about how high and low pressure regions are created on Earth. We'll use a local example. Picture a dark-colored parking lot next to a grassy field or park at sunrise. As the day progresses, which area will get hot faster? What will happen to the air over that area? Pause the video and write a brief answer in your notes. You'll include this answer in the Kia survey after you have finished taking the video notes. We're going to start off in the morning. Both areas have cooled off through the night. At the 500 millibar level, about half of the atmosphere is below and half of it is above. This occurs around 5,500 meters or 18,000 feet in altitude. When the surface atmosphere is referred to, we are talking about the first mile or 1,500 meters of air. Now the 500 millibar level is not fixed. It will change with differences in surface air pressure. Let's look at how that happens. As the day progresses, the sun shines on these two neighboring areas. One will warm more quickly than the other. The area over the parking lot expands more than the area over the park. This causes a change in the height of the 500 millibar level over each area. You can see that this area has expanded because it's warmed more. This area has contracted some. It hasn't warmed as much as the parking lot area. The surface pressure remains the same since both columns still contain the same mass of air, but the 500 millibar surface over the parking lot is displaced upward in the warmer column. The 500 millibar level over the park is displaced downward since it's the cooler column. This leads to a new lower 500 millibar level over the park. Now there's a pressure difference in the place above the surface. This difference in pressure will eventually have to be balanced. Something to know here is that fluids will always move from an area of higher pressure to an area of lower pressure. Where will the movement begin? Near the surface or near the middle height of the column? Right. The pressure difference for now is at the middle of the column. Once the air movement begins, however, the pressure at the surface will change. What do you think will happen at the surface level? What will you feel if you're the guy in the parking lot? The guy in the parking lot will feel the wind coming from the park. So you can see an area of higher pressure moves to the area of lower pressure. This displaces some of the air in the columns, creating a pressure difference down here at the surface. This higher pressure area will have air molecules that will move towards the lower pressure area. Now this is just a small local example of how air pressure changes can cause wind. The wind that you feel that lasts all day, like on a windy day, is caused by larger air mass movements that we will learn about when learning more about weather. So let's do a quick review. The atmosphere is held to the Earth by gravity. The pull of Earth's gravity on the atmosphere creates what we call air pressure. Standard sea level pressures of air. And there are 3 of them. Can you think of them? 14.7 pounds per square inch, 29.92 inches of mercury, and 1013.25 millibars. So pounds per square inch, inches of mercury, and millibars. These are the units you need to remember. A little more review. The tool used to measure air pressure is called a barometer. Air pressure occurs from above and around any object on Earth. Straws, suction cups, upside-down cups with cards on them, all work because of air pressure. Air pressure can change with influence from, there are two of them, temperature and altitude. Changes in temperature in one area can cause a change in air pressure compared to another area and begin a movement of air molecules known as wind. Lastly, some review on wind itself. It is the horizontal movement of air. It moves from areas of high pressure into areas of low pressure. The cause of local wind is called a pressure gradient force. Now, a pressure gradient is a pressure change over distance. These can be local or cover very large regions like the entire United States. Changes in air temperature cause changes in pressure, which result in wind caused by pressure gradient force. Be sure that you enter your answers to the questions that were asked where you were asked to pause the video. Go to the Kia survey in my Kia profile. It's called Air Pressure and Wind Video Notes Questions. The secret word to get into this survey is notes. Make sure that you enter your answers into the Kia survey to get credit for doing this homework. Let's review some specifics about wind. It is the horizontal movement of air. It moves from areas of high pressure into areas of low pressure. The cause of local wind is called a pressure gradient force. Now, a pressure gradient is a pressure change over distance. These can be local or cover very large regions like the entire United States. Changes in air temperature cause changes in pressure, which result in wind caused by pressure gradient force. Be sure that you enter your answers to the questions that were asked where you were asked to pause the video. Go to the Kia survey in my Kia profile. It's called Air Pressure and Wind Video Notes Questions. The secret word to get into this survey is notes. Make sure that you enter your answers into the Kia survey to get credit for doing this homework.